Alright, so in this problem, I have 3 to the power of x times 5 to the power of x squared is equal to 15. So to solve this, I'm going to first start by rewriting 15 as 3 times 5. So now I have 3 to the power of x times 5x squared, 5 to the power of x squared is equal to 3 times 5. Now, I'm going to divide both sides by 3 to the power of x, as well as 5. So then for my left-hand side, both the 3 to the power of x's cancel out. For my right-hand side, both the 5's cancel out. So now I get 5 to the power of x squared over 5 is equal to 3 over 3 to the power of x. Now, if I have something in the form 1 over a, this is the same thing as a to the power of negative 1. So 5 to the power of x squared over 5, that's the same thing as 5 to the power of x squared times 5 to the power of negative 1. And now this is equal to 3 times 3 to the power of negative x. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So, in this case, I get 5 to the power of x squared minus 1. And now this is equal to 3 to the power of 1 minus x. Now, if I take the log on both sides, I get log 5 to the power of x squared minus 1 is equal to log 3 to the power of 1 minus x. And if I have something in the form log a to the power of b, I can move this exponent and b to the front, so it's going to equal b times log a. So in this case, I get x squared minus 1 times log 5 is equal to 1 minus x times log 3. And now, I'm going to take base 5 on both sides of both logs, so these cancel out to get 1. So now I have x squared minus 1 is equal to 1 minus x times log base 5 of 3. And this means that x squared minus 1 plus x minus 1 times log base 5 of 3 is equal to 0. And this gets me to x minus 1 times x plus 1 plus log base 5 of 3 is equal to 0, meaning this is one equation, x minus 1 equals 0, meaning x is equal to 1, and if you solve this, you get x is equal to negative log base 5 of 15. Alright, so in this problem, I have a to the power of 3 plus a squared is equal to 80. So to solve this, I'm going to first start by subtracting 80 on both sides. So I get a to the power of 3 plus a squared minus 80 is equal to 0. Now I'm going to rewrite this as a to the power of 3 plus a squared minus 64 minus 16 is equal to 0. So I simply wrote negative 80 as negative 64 minus 16. And now, negative 64, I'm going to rewrite that as negative 4 to the power of 3. So I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 16, I'm going to rewrite as 4 squared. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is going to equal a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, if by using these two properties, I'm going to end up with a minus 4 times a squared plus 4a plus 16 plus a plus 4 is equal to 0. And this simplifies to a minus 4 times a squared plus 5a plus 20 is equal to 0. So now this gives me two equations. I get a minus 4 is equal to 0, and a squared plus 5a plus 20 is equal to 0. So for a minus 4 equals 0, a is obviously equal to 4. And for a squared plus 5a plus 20 equals 0, I'm going to use the quadratic formula, but I'm actually not going to waste your guys' time by actually doing it. So if you do end up doing it, you get that a is equal to negative 5 plus or minus the square root of 55i over 2. And the reason, actually what you should get is a equals negative 5 plus or minus the square root of negative 55 over 2. And the square root of negative 55, I can rewrite that as the square root of 55 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So if I replace I with the square root of negative 1, I get a is equal to negative 5 plus or minus the square root of 55 I over 2. So that's how I got square root of 55i. Alright, so in this problem, we have the square root of 3 to the power of x is equal to 81. Now, to solve this, I'm going to start here with the square root of 3. So let's just ignore everything else for a second and focus on the square root of 3. Now, the square root of a number is, say, the square root of x. This is the same thing as x to the power of 1/2. Because basically, the root here is 2, but we just don't write that. And the cube root of a number, that's that number to the power of 1 over 3, because we have a 3 over here. So the square root of 3, we can think of 3 as x in this case, and we can rewrite this as 3 to the power of 1/2. So now, if I substitute in 3 to the power of 1/2 for square root of 3, I get 3 to the power of 1/2 to the power of x is equal to 81. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 1/2 to the power of x, that's going to equal 3 to the power of 1/2 times x, which is simply 1/2 x. And this is equal to 81. Now, 81, that's the same thing as 3 to the power of 4. So now I have 3 to the power of 1/2 x is equal to 3 to the power of 4, and this means 1/2 x is equal to 4, and x is equal to 8. So 8 is my answer. Alright, so in this video, I'm going to solve the equation 9 to the power of x is equal to 36. So, to solve this equation, I'm going to first start by taking the log on both sides. So I get log of 9 to the power of x is equal to log of 36. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I have log 9 to the power of x, and I can move x to the front, so I get x times log 9 is equal to log 36. And from here, I can divide both sides by log 9. So these two cancel out, and I get x is equal to log 36 over log 9. Now, I'm going to rewrite log 36 as log of 9 times 4. So I did this because I can use the property log of a times b is equal to log a plus log b. This case, this turns into log 9 plus log 4, and I have this over log 9. So now this is equal to log 9 over log 9 plus log 4 over log 9, which is equal to 1 plus log of 2 squared over log of 3 squared. And if I have something in the form log of a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I can move 2 to the front over here, 2 to the front over here. So I get x is equal to 1 plus 2 times log 2 over 2 times log 3. From here, I can cancel out these two 2's. So I get x equals 1 plus log 2 over log 3. Now, log 2 is equal to 0.3010, and log 3 is equal to 0.4771. So if I divide these two, I get x equals 1 plus 0.6309, meaning x is equal to 1.6309. So this is my answer.